very important topic, imbalanced dataset. So this imbalanced datasets typically has something called as majority class, male category as 500 and female. So if I provide the same data set without handling this imbalance, right, to my model building or model training, this is the target label where you say that whether it is fraud or not fraud. So now let's see few of the techniques or steps to handle. It means you are adding 800 more data points. Which one is better, whether it is oversampling or undersampling? And this F1 score is the combination of your precision. I'll take in the two classes, and then I am taking the number of samples as 1000. You can see this class distribution, right? So these are the distribution. Basically, this is coming from this value. Hey guys, welcome back to my YouTube channel. This is Ashok, and today in this video, we are going to discuss a very important topic, imbalanced dataset. So this imbalanced dataset in machine learning typically refers to a dataset where the distribution of classes or labels is actually skewed, meaning that one class is significantly more dominating or more prevalent than the other. So this imbalanced dataset can be a challenge for the machine learning models, specifically if you are working on the classification tasks or classification use cases, as these models may be more biased towards the majority class and perform poorly in case of minority classes. So let's dive in and dig deeper into it. So this imbalanced datasets typically has something called as majority class and the minority class. So let's take an example, right? So I'm taking the data set, right, where I'll have some male and female categories, right? So this is just for simplicity, right? So I'm just taking a small example. Here I'm taking feature 1, feature 2, feature 3, and this is our target variable, or you can call it as class, or somewhere it is called as category. And suppose we have some features here and it is male, some features here it is male, some features here it is female, some features here it is female. For this I have 1000 data points. It means that I have 1000 data here. And suppose out of these 1000 data points, I have in the data set, suppose male category as 500 and female category as 500. So in this case, I can say that this data set is balanced data set, right? And suppose out of the same 1000 data points, you have male category as 900 and female category as 100. So in this case, this is called as imbalanced data set. And this male category is basically, as we discussed, is a majority class, and this is minority class. So this is basically a small example just to make you understand what is the imbalanced data set. So now let's see another example, right? So let's take cats data and dogs data. Basically, these are images. And in our data set, 95% of the data set belongs to cats and 5% data set belongs to dogs. This is again a majority and this is minority. So this is also an example of imbalanced data set. So if I provide the same data set without handling this imbalance, right, to my model building or model training, right, in that case, what happens is like my model, which is going to predict, right, so it is more biased towards this majority class. So here it in this case is cats and the male. So it means that your machine learning models or algorithms will produce the biased results. So I'm providing you a few of the real life sample data set, right? You can see like spam filtering, fraud detection, customer churn run. These are few of the use cases where you can get this imbalanced data set. So here in the spam filtering, you can provide email ID, right? And you can say subject line, and you can say body content. You can say it is spam or not spam. So basically you can have one email ID, subject line, body content. Here it is say spam, and you can say it might be few features and you say not spam. Similarly, you have feature not spam, and similarly you have not spam. You can see that based on these features, right, it will predict, it will classify whether it is spam or not spam, right? So this is one example. The other example, if you can see, is the fraud detection, right? So in this case, right, fraud detection, you might have seen the examples of credit card fraud, right? So a lot of cases has happened credit card. Here in this case, you can see transaction ID, user ID, items purchased, amount, location, and this is the target label where you say that whether it is fraud or not fraud. Based on this data, you have some features and it says not a fraud. Here it says again it is not a fraud. Here in this case you can say it is fraud, right? So again, if we see this data set, right, this is imbalanced data set, right? Because here you can see the majority class as not fraud and minority class as fraud. Here In this case also it will be not a spam is a majority class and spam is the minority class. Next data set you can see is for customer churn, right? So you can see user ID, you have a subscription and usage history, and whether they are churning or not, right? So you have some features here, and you say not churn. Here features you have not churn, and few features here you can say this is churn, right? These are few of the use cases where this imbalanced data set can occur, right? So I have provided this example just to make you understand, right? So whether it's spam filtering, fraud detection, or customer churn. So apart from this, you can have multiple use cases, right? Multiple data set you can find, where you can find it for earthquake data set, you can say it as cancer data set, or some kind of anomaly detection also, right? So now let's see few of the techniques or steps to handle these outliers. So the first step in this is data sampling. So in this data sampling, we have something called as oversampling and undersampling. Basically, this data sampling will balance your majority or minority classes or some kind of distribution, right? So it will properly distribute the data set. That is the use of this data sampling. In the oversampling, you have random oversampling, and you have something called as SMOT, which is nothing but synthetic minority oversampling technique. So now let's take a small example, right? Suppose I have 1,000 data points of cats and dog images. So suppose this is cats image, and this is dog's image, right? And this, out of 1,000 data points, 900 belongs to cat and 100 belongs to dog. Now this is imbalanced, we know that, right? So what happens in this oversampling? Oversampling always deals with the minority class, right? This is a minority class and this is majority class. So what happens in oversampling, right? So what they will do, they will add some of the images of dogs in such a way that this will also become 900. So it means you are adding 800 more data points of dog images to the data set, so that your cat and dog images are balanced. Now after this oversampling, your cat images are 900 and your dog images are also 900. So you are balancing this data set. That's what is done in data sampling or oversampling typically. So now let's understand undersampling, right? So I'll take the same 1,000 data points of cat and dog images, right? So let's say this is cat and this is dog. Again, this is majority, this is minority, right? This is 900 and this is 100. So what happens in undersampling is it typically deals with the majority class, right? It will not touch the minority class. So what happens in this is it will reduce the data points and make it as, to balance with the dog, they will make it as 100. So out of the 900, they will reduce the data points in such a way that data set will become 100. So it means that you're losing some data here, right? So cat, they will make it as 100, and also dog, they will make it as 100. That is undersampling. You're reducing some data here, right, of the majority class. So guys, task for today for you guys is, right, I want you guys to let me know in the comment section which one is better, whether it is oversampling or undersampling, right? Apart from this, I want you guys to explore this SMOT technique, synthetic minority oversampling technique. So explore this and provide some details, some information about SMOT in the comment section. I'll go through this and I will discuss in the next video. The point number 2, algorithm selection, or you can say machine learning model selection, right? So now there are some algorithms or models which are more robust or more resilient to this imbalanced data set, right? Some examples of these models or algorithms are decision tree, random forest, and SVM. SVM is nothing but support vector machine. So now we saw different techniques to handle this imbalanced data set, right? So let's see now evaluation with this imbalanced data set. So when you are evaluating your models or algorithms which are trained on this imbalanced data set, right, it is very much important for us to know which of the metrics which you have to use, which will take the combination or consider both the classes, right, whether it is the minority class and the majority classes. And such metrics which will be used to evaluate your model algorithms is F1 score, and you can use confusion matrix. So this we'll discuss in our coming videos. And this F1 score is the combination of your precision and recall. So let me open my Jupyter notebook just to show you the distribution of this imbalanced data set, right? Let's go ahead. Let me go ahead and create a new Python kernel here. So guys, I've taken a sample Python code just to show you like what is the imbalanced dataset and how those classes or categories distributes, right? So let's see how this Python code works, right? So I have imported few of the libraries specifically. These are common like NumPy pandas I've imported. I imported the Seaborn for visualization, Matplotlib also for visualization, and just to import the dataset, I've imported this dataset, and from this I am importing the make classification. So what I'm doing here is generating the synthetic imbalance data set, right? So you would say X and Y category, and then make classification is from this particular import. I'll taking the two classes, and then I'm taking the number of samples as 1000. And the next step I'm doing creating a data frame, right? So I'll create a data frame and create a features like feature 1 and feature 2, and then target will be the Y. So what I'm doing in this particular logic is I'm visualizing this class distribution, right? So from this SNS or the Seaborn, I'm taking the scatter plot, and I'm passing this data to this scatter plot, and then I'm taking the features X and Y, like feature 1 and feature 2, and then at the end I'm saying plot.show. This piece of logic is basically to display the class distributions, right? So I say df of target dot value counts. Dot value counts will basically give you the number of categories, number of classes in this particular data set, right? So let's run this and see. So you can see here, right? I got this distribution of imbalanced data set, right? So you can see the class distribution here, right? So class 1 categories have 900 data points, and class 0 categories have 100 data points. This is the example of your imbalanced data set, right? So let's take another example where in the last example I took number of classes as 2, right? So here I'm taking number of classes as 3. So you can see n underscore classes as 3. The rest of the code is same. So let's run this. So you can see this imbalanced data set with 3 classes, right? So you have see the distributions, right? So you can see this class distribution, right? So these are the distribution. Basically this is coming from this value counts, these values, and class 2 basically has the 700 data points, and class 1 having 200 data points, class 0 is having 100 data points. So guys, I want to give you one more task here. We saw this imbalanced data set regarding the classification use case, right? Some classes are there, then we have seen this imbalanced data set. I want you guys to explore how this imbalanced data set will work when you have regression analysis or regression use cases. Okay guys, that's it from my side for this particular video. So in this video, you have discussed about imbalanced data set, few examples of imbalanced data set, and we saw a few techniques to handle this imbalanced data set, right? And apart from that, we have seen few sample Python code to basically see the distribution of this imbalanced data set, right? And apart from this, I have given a small task for you guys to explore. Thanks for watching. If you like this video, hit the like button. Please subscribe to the channel, share with all your friends. I'll see you all in the next video. Till then, take care, keep learning, and keep rocking.